Hello everyone, and welcome to the 11th part of the MOOC dedicated to hydrocracking. In the first part, the hydrocracker was relocated into the refinery and the reaction section was described. Then we started talking about the fractionation section, especially the stripper and gasoline debutanizer. So let's now have a look at the future of the stripper bottoms. The stripper bottoms is typically at a temperature of about 215 degrees C. It's now necessary to increase its temperature up to 375 degrees C to separate the finished products. This temperature is very similar to that of a fractionation of a crude oil in an atmospheric distillation. We have heat exchangers to raise the temperature, and we finished the preheating of the column in a furnace to reach 375 degrees C. We need here a duty of about 16 gigacalories per hour, but we may have a different value according to the thermal integration on the unit. Then we enter the column, which is called the main fractionator. This column is equipped with about 60 trays and operates at a pressure close to atmospheric pressure. Stripping steam is also injected into the bottoms of the column to ensure an upward gas flow and facilitate the vaporization of hydrocarbons. Here, about 4 tons per hour of stripping steam is injected. In this column, we will not have a gas outlet, since all the very light molecules have been removed in the upstream equipment. But we will have an excess of liquid reflux that constitutes the heavy part of the gasoline. We will have a side row for kerosene and same for the diesel cut. And we recover the unconverted VGO in the bottoms of this main fractionator. From a mass balance point of view, we will have about 15 tons per hour of gasoline, 40 tons per hour of kerosene, 60 tons per hour of diesel, and about 20 tons of unconverted VGO. We usually equip the kerosene side row with a side stripper to correct the lightens content and therefore its flash point. I invite you to watch the MOOC dedicated to atmospheric distillation for more information on the operation of a side stripper. This tower is also most of the time equipped with pump rounds to recover extra calories. For example, here we got one on diesel cut and one on kerosene cut. All the cuts are then cooled before being routed to stock. When these finished products are cooled, the calories are obviously recovered to heat the flows that need calories in the process. Indeed, remember that calories were needed to heat the VGO when it was not yet in the reaction section. Note that the overhead gasoline stream is mixed with the debutanized gasoline, and everything is routed to another column called a naphtha splitter. This naphtha splitter typically works at atmospheric pressure and is equipped with about 20 trays. It is recalled that this column therefore treats the 15 tons per hour of debutanized gasoline plus the 15 tons per hour of fractionation overhead, for a total flow of 30 tons per hour. About 6 tons per hour of light gasoline is recovered at the head of the column and 23 for heavy gasoline. Light gasoline can be a good feedstock for a steam cracker when heavy gasoline is usually routed to the refinery reformer to increase its octane number. Here we are at the end of the description of the process. Go to the last video to talk about the properties of the products. Well, that's it for this video. I invite you to do the quiz and to subscribe to my YouTube channel before jumping to the next and last video. See you very soon. Bye bye!